Morning Year 11. In this review we're going to look at the insertion sort. I'm paying particular attention to the homework questions because there was two questions that caused everyone problems, and that was questions 3 and 6, which asked you to demonstrate the algorithmically how the insertion sort works. Remember, two loops. In the outer loop we iterate from left to the right of the array. In the inner loop we're looking from the right to the left to make the insertion. We always consider the first element sorted at the beginning of the algorithm. So bearing that in mind, we can see that element 2 is going to be sorted, so I'm starting the pass with number 1. 1 is less than 2, there's going to be an insertion, so that gives us 1 and 2 are sorted, then 4, 3, 6, 5 and 7. So 1 and 2 are sorted. I'm now looking at this third element, the number 4. 4 is not less than 2, there's no insertion, so there is the state of the array. We're going upper iteration 3, 3 is less than 4, there's going to be an insertion, and the remaining unsorted numbers. I'm now looking at element 6. 6 is greater than 4, there's going to be no insertion. And we're up again and we're looking at number 5, and I'm looking down the list. 5 is less than 6, there's going to be an insertion. 5, 6 and 7, and our algorithm completes and we're out of space for that question. And the same problem presented itself in question 6. Remember, considering 9 sorted, so I'm starting the iteration at 3. 3 is less than 9, so we've got 3 and 9 sorted, and that leaves 5, 4, 7, 2, 1, 6 and 8 are unsorted. So the next stage, I'm looking at 5. 5 is less than 9, there's going to be an insertion. So it'll be 3, 5, 9, they're sorted. Unsorted 4, 7, 2, 1, 6, 8. I'm now looking at 4. 4 needs to be inserted into place. 3, 4, 5, 9, 7, 2, 1, 6, 8. I'm now looking at the value 7. 7 is less than 9, it needs to be inserted. 3, 4, 5, 7, 9, 2, 1, 6, 8. I'm now looking at the element 2. It's less than all of them, it needs to be inserted. 2, 3, 4, 5, 7, 9, 1, 6 and 8. Those values are in place. But a point to note is there is still 3 iterations left to complete, and that gives you your question for part B. How many iterations would we need to do? So now's a good time to pause the video or rewind and look at the mechanics of the insertion sort algorithm, and I will take a quick look at the Pig Latin question. This is just one way of solving it. The big problem is the mechanics. Do I have Pig Latin rules? So Wikipedia told us there's pretty much 3 main cases, and I've simplified it, but we could develop it. I'm considering it begins with one consonant, it's got 2 consonants at the beginning, or it's got a vowel, and that's what I'm looking at in this simple programming. It begins with a function that's going to take in one parameter. We're going to pass in a value, which will be a piece of text. For example, computer will be passed into this function. I've started with an array of vowels. Rather than writing out an array of 21 consonants, I'm just going to use the vowels. And I'm checking the first element, text 0. If text 0 is not in vowels, we know it's a consonant. And if text 1, the second character, is not in vowel, we know it's a consonant. So it meets the rule for a word beginning with 2 consonants. And Wikipedia told me, well, if it's got 2 consonants, clusters of consonants, what we do is we strip off the consonants, we put them at the end, and we append in an A sound, AY. So look, I'm returning the original text stripped from character 3, that will give me the first 2 characters, to the end. I've left that side of the slice blank, and that means to go to the end. I'm concatenating or joining it from the first character to the second, and I'm putting in A. So if it comes across, for example, science has got 2 consonants, it will strip off science, the SC, it will put the SC at the end as well as an AY. If it's just text 0, if it's just the first text that's not in vowels, therefore it's a consonant, it's going to return the text from the second character, index 1, to the end. Again, I've left that blank, concatenated with the first character plus an A. So computer would lose its C, it would be put at the end with an AY. And then else, it must begin with, pardon me, a vowel. We just append say on the end of the word. So we've got three clauses. Now I mentioned I did generalize this. I could expand that to put in some OR logic here, or text 0 not in vowels, and text 1 not in vowels, and text 2 not in vowels, do that. Or text 1 not in vowels, text 0 not in vowels, text 1 not in vowels, text 2 not in vowels, text 3 not in vowels, do that. But look, to be honest, I don't know too many words that start with more than 3 consonants, so I've just left it like that. And when we run it, we will see the 3 different cases are accommodated. Computer becomes Computerke, Einse or Hoise. And that is just one solution. I'll post the link with the video along with some of your own examples. Have a good weekend, and remember, we meet again next Monday.